Example 7. Given n of x is equal to x squared plus 1 for x is less than or equal to 0, write an equation of the inverse. This problem actually had to have the domain restricted on here because when you take a look at x squared plus 1, it will draw a parabola that looks kind of like this right here. And since our inverses are supposed to be symmetric across the y equals x line, that means its inverse is going to be located right here. And this is not a function. So what they've done is they've said, okay, let's just look at the negative side of the parabola. Then the inverse should also be the negative side of the parabola. So we'll take this piece away right here. And so that is what we are trying to find the inverse for. We're trying to find this equation right here. All right, so keeping the same steps, we're going to take out the n of x. We're going to replace it with the y. So we've got y is equal to x squared plus 1. And we'll interchange the places of the x and the y. So this is going to give me x is equal to y squared plus 1. And now we're going to solve this problem for y. So let's subtract 1 from both sides. This is going to give me x minus 1 is equal to y squared. And then to solve this, I'm going to square root both sides. And we know that the square and the square root are going to cancel out. And don't forget, this side we want positive and negative. Whenever you square root something, you want plus or minus. So it looks like y is going to be equal to, now remember we don't want both of these because we only want the lower half of this one here. So that means if I'm looking at the part that's less than 0, I do not want to have the positive square root. I am only concerned with the negative square root of x minus 1. And now we'll just replace the y with the inverse notation. F inverse of x is equal to the negative square root of x minus 1. And I'm going to change one thing here. Instead of having f, we should write this as n inverse of x is equal to the square root of x minus 1.